It's time to talk about insects again, and today I wanted to talk about murder hornets. Now, you may be already a little familiar with murder hornets. These are the giant Japanese or giant Asian hornets that are extremely poisonous. They are very, very large, about the size of your thumb, sometimes bigger, and they can produce and inject enormous amounts of venom and are easily capable of killing small vertebrates with a single sting. And a multiple of these attacking larger vertebrates or large mammals will kill them fairly easily. And in 2019, these started showing up in North America, having been eradicated, I believe, by 2021. Generally speaking, hornets and wasps are very good at colonizing new areas because they tend to be generalist predators. So a single mated queen can establish a colony fairly easily and survive on basically whatever is in the environment. These ladies are particularly known for their giant stingers. So not only are they enormous, but they have this 6 millimeter stinger attached to a large venom gland that is extremely painful when they inject you. These sorts of murder hornets are serious pests of honeybees, capable of wiping out entire colonies if just a few of them attack. The Asian honeybee has an interesting way of dealing with this, though. They are capable of massing onto these hornets and raising their internal temperature above 100 degrees in order to cook the hornets at the center of these balls of East Asian honeybees. Why I'm bringing up murder hornets now, though, is because new research was published this year showing that murder hornets have a problem. And that problem is the common pond frog. Researchers have discovered that the common pond frog, Pelophylax nigromaculatus, has a huge resistance to the venom of these murder hornets, which is really saying something because these murder hornets have a complex venom that both causes a ton of pain and breaks down the local tissue, and also has a number of neurotoxins in it, which can stop the heart of vertebrates. But it appears that no matter how many times these frogs will be attacked by murder hornets, they don't seem to be affected by them. In the laboratory setting, these common pond frogs were fed a number of live murder hornets and their related species. So the most well-known of these murder hornets is Vespa mandarinia, but there are a number of other similar hornets in Japan. So you have Vespa similima and Vespa analis, and these frogs were fed these murder hornets in cages, the murder hornets being alive, and in almost all cases, the frog attempted to eat the hornets. Most of those attacks against the hornets ended in successful predation. The reason researchers were even inspired to go down this route is that hornet remains were found in the stomachs of pond frogs on a pretty consistent basis. So the question was, is it that the frogs are somehow avoiding the stinger, or is it that the frogs are resistant to the stings? Avoidance of stingers is pretty common in nature. Sometimes birds that will feed on hornets and wasps and things will rip off the abdomen of the hornet or wasp before devouring the front half of the insect. The same thing with spiders. One of the reasons that they have webs is that they are capable of incapacitating these sorts of wasps and that before they have to feed on them, thus avoiding the stinger. But a lot of animals do this where they will either cut off the stinger or somehow incapacitate the stinger in order to feed on the Hymenoptera. But in this case, the frogs just went all in. They made no attempt to incapacitate the murder hornet. They made no attempt to remove the abdomen. They just are whole feeders, so they swallow the insect whole, and they just allow the stinging to occur. And these stings were occurring all over the frog's face. They were stung in the eyes, they were stung in the mouth, both on the lips and inside the mouth. They were stung in the throat, and the frogs just don't care. You can see the stinger piercing through the lip here. That's what this is. You can see this enormous stinger coming through here, and you can see the stinger again passing through the throat here. That's what this highlighted area is. The frogs just don't care. So enormous amounts of venom are actually being injected into the frog with each of these stings. And as far as the researchers could tell, there was no change in behavior from the frog. They didn't seem to be harmed by this sting at all, no matter how many times they were stung. They didn't have any sort of inflammation response. They didn't have any behavioral changes. They certainly didn't die, which is kind of surprising considering that these stings are capable of individually killing mice and rats. So a single sting easily kills a mouse. And these frogs aren't that much bigger than, a fat mouse. So this has raised new questions about the nature of toxin resistance in these sorts of predators. Frogs are generalist predators, so they're not specifically evolved for hunting down stinging insects. So it's not like they would have a specific immunity to this toxin, at least we don't think. It's possible that frogs in general are resistant to stinging insects because stinging insects haven't evolved a specific toxin for amphibians. Generally speaking, stinging insects are most concerned with birds and mammals. It's not like frogs are going to invade the hive of bees or wasps or hornets. Generally, it's some sort of mammal that gets in there, like mice or bears or, raccoons, things like that. So it's possible that just amphibian physiology is not particularly susceptible to this sort of venom. We don't really know. So this research has just raised more questions about why is it that this particular dangerous hornet has just met its match in this very normal frog. So I'll post the link to the research in the description. It's not very long if you want to read it yourself, and I'll talk to you later.